Okay, good morning. This is a pre-taped hardware tutorial for ECE 2372 on Tuesday, November the 15th. So today I'm gonna show you briefly how to use the hardware, the digital design kit, to build up a simple system. And after that, I will assign the third project. It's gonna be a very simple hardware project to implement a 2 to 4 decoder. Okay, so if you have gone to the IEEE office, you will purchase the digital design kit. You have basically two boxes. One is this box with the components, the wires, the resistors, and also the capacitors inside it. And the other one is the breadboard. And it's like this, and you can take it out, and this is the breadboard. So those are all the things we need to build up the system, and it will be good if you can get some other tools like this, the stripper. If I have this, I can make the wire that I need. For example, inside the box I have wires like this, and I have this stripper to peel off the outside, and I can cut it. It's very convenient, and you can also borrow this from your friends or buy it from Radio Shack, Texas Electronics, a lot of places like this. I can make this wire. So after you have this wire, you'll have two ends that are ready to be plugged into the breadboard. Okay, like this. And you have 4 corners. And for my design, basically I'll use the red corner for the power for VDD, and the black line for the ground, and for the signals, for most of the time I'll use the yellow and the green lines to make the design clear. And on top of this black sheet, you'll have different components, so you can take it off. And today in my tutorial I will use basically two chips. One is the AND gate, another is inverter. Okay, and also, if possible, it will be good to have this multimeter. If you have the multimeter, you can measure the voltage, and also the soldering machine, and I'll just use it once. Okay, so let's get started. Let's look at the breadboard we have. So on the breadboard we have different holes, and as labeled here, this negative sign means normally we use it for ground, for the power ground, and all the holes in this row are essentially connected to each other inside the board, so you don't have to worry about them. All the holes like this line, they are connected together. And also for the plus sign, normally we use it for the power, so all the holes this line, they are connected together. Likewise, on the bottom side you have another ground, another power, and it should be careful that this line of ground, this line of ground, they are not connected. So if I want to connect them, I have to use external wire. So I'll have this black wire, and I'll simply plug in like this. So by doing so, this line is now shorted to this line. They are both my ground of the system. Okay, and likewise I can make a connection from the positive side to the other supply line like this. So now this is gonna be the power supply, 5 volts. This line is also 5 volts. Okay, and the next work is on the regulator. So what does this regulator do? It converts a high voltage to a fixed voltage of 5 volts. And if you want to learn the details, you can go to the website. I'll send you the link of this website. And on the website we have the data sheet of every component. So like here, I can click the data sheet for this regulator. And now we get the data sheet. On this data sheet, I think the most important thing is this footprint. So we have the regulator here, and this graph tells us this is the number 1 pin, and number 1 pin means the input signal, input voltage, and this is number 2. The pin in the middle is number 2, and it's gonna be the ground, and this is the number 3 pin, the output. So here, look at the components. This is the input voltage. It can be any voltage that is higher than 5 volts, and this is the ground, and this is the output voltage, which is regulated, and it's gonna be always 5 volts. This is important because for battery, as time goes by, the output voltage of the battery will drop. So we have to make sure after the regulator it generates a stable voltage of 5 volts. And because normally I have to always connect the battery to the 5 volt regulator, I'll simply solder the pins permanently. Like this is the plug for my battery. I can make this kind of plug, and now the red wire has the battery output voltage. The black wire is the ground for the battery. So I'll connect the red wire to pin number 1, the input voltage, and ideally I should connect the black wire to the middle pin. However, a more convenient way is I can connect the black wire to this panel, because this panel is also ground. It's shorted to the middle pin. Okay, so it's gonna be like this, and now I have to, so we know that this pin is my ground and this pin is my output 5 volt voltage. I can plug it into the breadboard like this. Now I'll turn on my multimeter to measure the voltage, to confirm the voltage is correct. So for the multimeter, I turn it to the voltmeter mode, put the negative probe to ground and positive probe first to the input voltage right here, and it shows that the input voltage is 6.6 volt from this battery, because my battery is relatively old. If you have new battery, the output voltage is gonna be 9 volt. Okay, and now I measure the voltage that I generated for the breadboard, the 3rd pin right here. Touch it right here, and it shows that the voltage is 4.96 volts, approximately 5 volts. So it's working well. Okay, and to save power, I'll unplug it first. Alright, and today I'll show you 2 simple examples of using breadboard to build up something. The first example is gonna be AND gate, and the second example is inverter. So for the AND gate, basically we have AND gate like this, and we have to provide supply voltage 5 volt connected to ground. So those are the power supply, 2 inputs and the output. And for the inverter, single input, single output, the power supply, the ground. And in order to check the output status, what I can do is I can connect the output to LED light. So this is LED light, okay, like this. So if the output is a high voltage, then the LED light will be on, and if the output is a low voltage, the LED light will be off, of course. Same thing here for the inverter. I'll do this. High will give me on, and low will turn off the LED. And this is the LED. You can find out from the digital kit. So I already get it off from the kit. This is the LED, and for the LED, we can check the data sheet again. Like here, LED data sheet. And the information here from the datasheet is for the LED, if I have this corner, this corner, it means this pin is pin number 1, and this corner is different from other corners. Other corners you have the straight 90-degree angle, and this corner it's kind of different, so this indicates pin number 1. And from here we can see between pin number 1 and pin number 20, pretty much this pin and this pin, we have one LED, and pin number 1 should be the positive in. So I'll make the connection on the breadboard. So before we do that, I'll briefly introduce the other holes on the breadboard. So on the breadboard, we have taken care of the power supplies, and for those pins, each column, for example, for the 25, we have 1, 2, 3, 4, 5. We have 5 holes. Those 5 holes are connected internally inside the breadboard. Likewise, those 5 columns for the 30, 1, 2, 3, 4, 5, those 5 holes are shorted. And also for every column, the 5 pins are shorted. Okay, and also for the lower side, the 5 pins in the same column, they are shorted. However, be careful that between the upper column and the lower column, those 5 pins, they are disconnected. Okay, so there is no connection between the upper part and the lower part. We only have 5 pins in each column that is shorted. So for the LED, I can simply plug it like this, plug it in like this. Okay, then now here, this means pin number 1 here, and it's gonna be connected to the other 4 holes on the board. And for pin number 20, it's gonna be connected to those 4 holes in the same column. Okay. And next, I have to find out what is my AND gate. So my first example is AND gate. Go down the website. Here we go. We have the AND gate here. And for the AND gate, the part number is 74HCT08. And search on this kit, you'll find the AND gate right here. 74HCT08, and you can ignore the letter E. Okay, so as long as we have 74HCT08, it means this is the AND gate. And for the AND gate, go to the data sheet. It's very straightforward. First, find out the semicircle, and on the chip we have the semicircle here. Okay, so as long as we can find the semicircle, we can find pin number 1, then from pin number 1 we have 1, 2, 3, 4, 5, 6, 7, and 8 this side, 9, 10, all the way to 14, pin number 14. And the next graph tells us the connection. So if we want to use this AND gate, this chip actually has 4 AND gates. If we want to use this AND gate, we have to use pin number 1 and pin number 2 as the input, and pin number 3 as the output. And for the power, this is the positive power supply, pin number 14, and pin number 7 is going to be the ground. So I'll put this chip on the breadboard, and again put it in the center. Okay. Sometimes you have to tweak the pins a little bit to fit in the pitch of the holes. Okay. So now we have connection like this, and this pin number 14 is gonna be my power, and this pin number 7 is my ground. So I'll make the connection. For the ground, I'll use the black wire. Oops. So this is the correct connection. this side connected to the negative power supply, the ground, and this side I can connect it to any of the 4 pins in this column, and then from here it's gonna be connected to pin number 7 using the breadboard. Okay, and same thing, we can make the connection for the power. So for the power, I can do this. Connect one end of the wire to the positive supply, and connect the other end to the column for pin number 14. So now this is taken care of, and next we have to worry about the light. So LED light, go up. LED light is here, datasheet. And one thing very important for the LED light is the typical, right here, the typical voltage, forward bias voltage is 2 volt. However, the regulator we have generates a voltage of 5 volt. What does that mean? It means it may burn our LED. The maximum allowed voltage is 2.5 volt. So we have to generate a 2 volt, approximately 2 volt voltage for the LED. And what we can do is we make this kind of connection. The negative side is still grounded, and for the positive side we have to use a resistor to connect it to 5 volt. And we have to calculate the voltage divider approximate resistance to generate a voltage that is between 2 and 2.5 volt. So in order to do so, this voltage is halfway between 0 and 5. So it means we have to make this resistance to be approximately the same as the resistance of the LED. And I've got to figure out what is the resistance of the LED. From the table here, it shows that with the typical voltage of 2 volt, the current, steady current, is 30 milliamp. Okay, so 2 divided by 30 milliamp, that's gonna be, calculator, 2 divided by 30, okay, that's gonna be 0.067 kilo ohm and approximately 670 ohm. Okay, and if the voltage is higher, because the voltage can be from 2 volt to up to 2.5 volt, so the resistance could be a little higher than 670 ohm. And as a matter of fact, on our design kit, we can find out the resistance, and turns out this resistance is approximately, this resistance is 1 kilo ohm, which is closer to the 670 ohm. Okay, so I can use this resistor, and I have to find out this resistor from our digital kit. And in order to find it out, we have to look at the corners. Be careful that every resistor has a different corner. So in order to find out this resistor, we have to match the corner, and actually I already have the resistor here. See? Brown, black, red, and yellow. So this means this is a resistor with 1 kilo ohm resistance. Now I'll just try out if this resistor works. Get this kind of connection, then I should be able to turn on the light. So for this side, the positive, actually it's upside down. Look at the data sheet. The positive in is pin number 1. So, and this is pin number 1. Okay, so this is a positive in I have to connect it to plus the positive power supply, and the other side I have to make a connection for the ground. So this side I'll make a connection for pin number 20 to ground, like this. And now if I plug in the battery, see, the light is on. Okay. Alright, great. And now we can build up our logic. For the AND gate, again, this is the data sheet for our AND gate, and for the AND gate, output is pin number 3. So the light now here should be connected to, instead of 5 volt, should be connected to the output of the AND gate, like this. Okay, so I'll make a connection from here to the output pin number 3 of the AND gate. Okay, great. And next I have to take care of the input. So for the input, I'll find a longer wire. So for the input, I'll use the yellow wire and the green wire for the signal. This yellow wire connected to pin number 1, pin number 1, one input of the AND gate, and another one connected to pin number 2, the second input of the AND gate. Now I turn on, I plug in the battery, power on the system. First example, if I have 1 as the input, then output should be high, the light will be on, right? So I connect the 2 inputs to the positive power supply, which represent 1. Okay, now as you can see, the light is on. And next, I'll check if I change the input to 0, 1. Suppose for the AND gate, output should be 0, so light will be off. So I'll connect the first input to ground, back to ground. See, now the light is off. Okay. And if I have 0, 0 as the input, of course the light also should be off. Okay, still light is off. And I connect 1, 1 back to the input, then the light should be turned on. Okay, so what we can do is we can change the input to be connected either the ground or the VDD, representing 0 or 1, and check the light. If the light is on, it means output is 1, and if light is off, it means output is 0. Very simple example. And next example is the inverter. So for inverter, it's not okay, and the part number is 74 HCT14, and it's 74 HCT. We should have another knot. Okay, this inverter knot, it's 74 HCT04, and this is 74 HCT04. So I plug it onto the breadboard, and I have to check the data sheet for the inverter. Alright, input is pin number 1, output is pin number 2, and again we have to connect the power supply VCC here for the pin number 14 and pin 7 for ground. And one thing is, for the power supply, the 5 volt supply power, sometimes we call it VCC and sometimes we call it VDD. Doesn't matter too much in our class. Okay, so I'll make a connection for the power. Let me find And okay, I'll just use this wire for the power, and I'll make a connection for the ground. And for the input, I'll use this wire, and for the output, again, we have to use the resistor to be connected to the output. So this is the output, pin number 2, connected. I'll use this light, the 7th light, for the inverter output. So make a connection like this. And also I have to connect the ground for the light. It's gonna be here. Okay. And for the input, pin number 1 of the chip, okay, pin number 1 connected here. Okay, and now we can try it out. Suppose if I have input of 0, then output will be 1, the light will be on. So check if I can get the light on. Oops, something wrong. Okay, this is a good example. Tell us how to debug the problem. Let's see what's the problem here. Oh, oops, I made a mistake here. For the ground connection, okay, I should do this. Connected to the ground. Okay, yeah, this is correct. So just now I mistakenly connected the ground to VDD, which is really bad. Okay, so now I have to connect the ground of the LED to ground. Okay, here. So now the input is 0 volts, and the inverter output should be high. Okay, inverter at this. Okay, output is high, light is on, and now I connect the input to VDD, and the light is off. Okay, pretty much that's all. That's all our demonstration for today. And for the project, we actually have the 3rd project, hardware project, and this project is simple. We already see that using those 2 chips, we can build up. We can have inverter and AND gate. And for the inverter, we have 8 inverters inside it. For the AND gate, we have 4 AND gates. So our task for project number 3 is to build up this 2 to 4 line decoder. So you have to get 2 inverters and make the connection for the 4 AND gates. And after that, you should have 2 inputs, A0, A1, and you have 4 output. Okay, and for the 4 outputs, connect them to the 4 lights, and show that for different combination of the input, you'll have one of the output to be high, so you can turn on one of the lights. Okay, so finally you have to demonstrate you have 4 lights controlled by your circuit, and you have 2 bits of the input, and you have to switch among different possible input, for example 0001, and check the output light, and demonstrate that the 2 to 4 line decoder works well. Okay, alright, I'll send you email of the link again, the link for the digital kit data sheet, and I'll also upload the requirement for project number 3 to Blackboard. Okay, thank you, enjoy.